the JAMA Network.
I'm Martha Claire Morris. I'm a professor of epidemiology at Rush University Medical Center in Chicago. I'm also director of the section on nutrition and nutritional epidemiology in the Department of Internal Medicine. Seafood consumption is recommended because of its many health benefits. But seafood is also a source of mercury, and mercury is a known neurotoxicant that perhaps can cause increased neuropathologies in the brain that are associated with dementia. In this study, we wanted to relate brain levels of mercury to both seafood consumption as well as the neuropathologies that are associated with Alzheimer's dementia, vascular dementia, and Lewy body dementia. The study was based on a cohort of community residents, all of whom had no dementia when they enrolled in the study and who also agreed to brain donation at death. The study, called the Memory and Aging Project, was conducted in the city of Chicago and surrounding areas and included residents of retirement communities as well as senior public health units. We assessed diet consumption in this community cohort beginning in 2004 on an annual basis. Participants were also annually evaluated for neurologic diseases, including Alzheimer's and other dementias. This study focused on the 286 participants who died and had a brain autopsy. The sample was, at death, 89.9 years of age on average, 67% female, and had an educational attainment of 14.6 years. We measured the neuropathologies associated with Alzheimer's disease, including amyloid plaques and neurofibrillary tangles. We also analyzed the brains for vascular dementia, including macroinfarcts and microinfarcts, and with Lewy body dementia, looking at levels of Lewy bodies in the brain. The brains were also analyzed for levels of mercury and selenium. We found that seafood consumption of one or more meals per week was correlated with higher levels of brain mercury. We did not find that seafood consumption was associated with increased levels of selenium in the brain. In addition, we found that seafood consumption of one or more meals per week was associated with less burden of Alzheimer's disease neuropathology, but only in people who had the apolipoprotein E4 allele. We did not find that seafood consumption was correlated with either neuropathologies associated with vascular dementia or with Lewy body dementia. We did find that seafood levels were associated with higher levels of brain mercury, but the levels of brain mercury were not associated with increased levels of any of the brain neuropathologies. In addition, we did not find that increased levels of selenium in the brain were associated with decreased levels of any of the brain neuropathologies. The study was funded by the National Institute of Environmental Health Sciences and also the National Institute on Aging. The next step of our investigation will be to look at whether seafood consumption is associated with markers of brain health, including increased level and density of presynaptic proteins. There is a body of literature in animal models that have found that DHA, one of the omega-3 fatty acids found in fish, is associated with higher levels of synaptic proteins in the brain, and that this might be one of the mechanisms by which seafood consumption protects against the development of dementia.